Okay, next up is the moment of a couple naman. So ano ba to? So, if you kind of think about it, what comes to mind when it comes to moment of a couple? So, pag-usapan natin muna siya. Oops, this is a different kind of moment. So, this is not the moment we're looking for, but it's a nice touch. It's a nice touch. So, technically, ito na siya. Ito yung actual moment of a couple. So, let's define yung terms lang muna natin. So, we have a couple and couple moment. A couple, basically, there are two parallel forces, and they have the same magnitude and are opposite in direction in this particular case, and they're separated by a perpendicular distance. Okay? A couple moment naman are two parallel forces, same magnitude, opposite direction, and separated by a perpendicular distance r. In this case, position vector r lang. Okay? So RAB is RB minus RA. Okay? So the scalar formulation pa rin is equals to moment is equals to force times perpendicular distance, and the vector formulation is just simply the cross product of position vector r and force vector f. A couple moment is a free vector. So in this case, yung r na to, it's just simply rb minus ra. So how to solve? So meron tayong tinatawag na equivalent couple, and they exist if two couples produce a moment with the same magnitude and direction, then these two couples are equivalent. So doon natin lang masasabi na equivalent couple sila when if two couples produce a moment or torque or moment of a force with the same magnitude and direction, then these two couples are equivalent. So recall natin na in this particular example, we have 30 newtons on this particular side and 30 newtons on this particular side separated by perpendicular distance of 0.4 meters. In this particular example, recall that we can actually solve the moment by getting the moment of each individual. So moment 1 plus moment 2. We can get yung moment nun from the center since this is perfect circle naman. So it's gonna be we can find yung moments 1 and 2 about yung point at the center ng circle na to. Okay, so that's gonna be force times perpendicular distance, 30 times 0.2. So in this case, yung force 1 dito, that's clockwise. So negative, um, para silang negative after. Hindi ko na nakalimutan ko ilagay. So negative 6 Newton meter. Ganun rin. So clockwise to negative 6 Newton meter. And you combine the moments together, M1 plus M2, you would have negative 12 Newton meter. There's another way to solve it. Ang tawag sa kanya equivalent coupled method. So you're gonna be using pa rin yung moment is equals to force times perpendicular distance, but instead of having yung perpendicular distance about the center about the center point, you get the whole distance kagad. So in this case, since couple naman sila, and you're gonna add them together, you use the entire force, 30 newtons, multiplied the entire perpendicular distance dito. In this case, 0.4. And then since it's clockwise, you know very well na it's gonna be negative. So negative 30 dapat nakalagay dito. Negative 30 newtons times 0.4 will yield you negative 12 newton meter. Think of it parang shortcut siya. No? And that exists perfectly well for equivalent couples scenario. So yeah, this is actually one of the perfect ones here. Now, what if there's multiple moments naman and they're not exactly the same like that particular flywheel naman. So we can talk about resultant couple moment naman. So if you recall, we have a solution by scalar analysis. When there's multiple moments, we get the summation of all the moments here. And summation of multiple moments is simply the summation of all the products of force and their perpendicular distances. However, it's a lot easier when we're talking about vector analysis naman kasi we're just gonna get the summation of all the cross products of respective position vectors and force vectors. So in this particular case, for example, this one, so M1 and M2. So we get the cross product ng M1, the cross product ng M2, and would yield yung resultant vector niya. Okay? So, again, let's try to solve a problem and to understand more about this. So we have a sample problem number 10 here, okay? We're being asked to determine the resultant couple moment of the three couples acting on the plate in the figure below. And by the way, class, you really have to understand the problem given to you if it contains couple moments. And again, if you're going to go back to the definitions, a couple moment exists when there's two parallel forces and they're opposing to each other and they have the same magnitude and they are separated by a perpendicular distance. In this particular case, I see three moments. So let's try to solve it, people. So determine the resultant couple moment of the three couples acting on the plate in the figure below. So from the figure, we have three couple forces, and I want to draw them to you. This is couple number 1, 200, 200, and then the perpendicular distance is 3 feet. No, sorry, 4 feet. There we go. Then we have couple number 2, so 300 pound force and 300 here. Separated by a perpendicular distance of 5 feet. So you could say that this is there, yeah, another couple. And then one last couple is this one, 450 pound force, 450 pound force, separated by the perpendicular distance 3 feet. Okay, so we have multiple couples here, and we're being asked to get the resultant couple. We can do this scalarly by just getting the. It's a lot simpler to do it, getting the sums of all the moments of each particular couple here. So we're going to use this particular formula here. And expanding that formula is equals to the moment 1 plus the moment 2 plus moment 3. Okay? So we can write that. You can solve this separately and then just add them all together at a later stage of your equations. Or you can all write it down. So for moment 1, so let's go with 200 muna. 200 using the equivalent couple moment method. So 200, instead of splitting it into 2, I'm just going to multiply that by its entire perpendicular distance. And this one is clockwise, so that's going to be negative 200 times 4. So, and then with moment 2, so we have 450 counterclockwise, so that's positive 450 times 3, and then moment 3 naman dito, even if it's an angle, okay lang yan. So that's gonna be clockwise, and minus 300 times 5. And the established equation is here. So negative 200 times 4 plus 450 counterclockwise times 3, and then clockwise naman si 300, clockwise dito. Kung mapapansin nyo, there's no about a particular point, and that's the beauty about the couple naman dito eh. You just have to pay attention yung ikot nila, about their center, about say, in this particular case, the rotation about, say, yung gitna ng 5 feet na to, which is 2.5, or in this particular case, yung gitna ng 3 feet na to, which is 1.5. So, pag ganito siya, ito naman, pag clockwise. Okay? So, susundan mo lang yung ikot niya. Saan sila pupunta. Okay? And the good thing about it is it's already indicated by its arrow. So it's a lot easier to identify whether they're positive or negative. So the resulting moment here, the resulting moment, the resulting couple moment resultant is negative 950 pound force feet, or simply 950 pound force feet clockwise symbol, and then write the word clockwise. Okay. We have one more example for a couple of moments. We have this naman. So this looks pretty familiar to the one we did on part 1 on force system resultants. So we're being asked to determine the couple moment acting on the pipe shown below. Segment AB is directed 30 degrees below the XY plane, so we have 30 degrees dito. That's fine. So that means this is also 30 degrees. Show the final answer in scalar form and vector Cartesian form, or Cartesian vector notation form. Okay. Again, it didn't say about what particular axis of rotation, but we know that there's a there's a couple moment here, which is 25-pound force going up, 25-pound force going down. Okay, and we need to know yung horizontal distance nila, horizontal perpendicular distance nila. And it's a good thing we're given an angle beta, so we can determine that directly. So no need for resultant couple of moments since there is only one observed couple forces here. Our solution can be approached either by scalar or vector. If we go vector, we can go about axis O or about a point along the line of action. Okay, so which one is the line of about axis O? This one, or line of action, which is this one. Okay, all right, let's try solving it one by one now. So we're gonna find your moment, yung the couple moment here. Okay, we can try solution A lang muna, scalarly, which is simply force times perpendicular distance. So all we have to do lang is just outline it lang. So what do we need? So we need force times perpendicular distance. And what is that perpendicular? We have force already. All we need to do and determine is yung perpendicular distance. A good thing we have dimensions here where we can use our trigonometric tools to identify yung horizontal distance, d, and which is simply the perpendicular distance d is 6 cosine 30 degrees. And all we have to do na lang and apply equivalent couple method. So we multiply 25, which is negative 25-pound force because it's clockwise. There we go. I forgot the negative sign lang dito. Sorry about that. So the answer will be negative 129.904 pound force feet, or 129.904 pound force feet, then clockwise symbol. Okay. In this particular case, it's going to be negative 129.04 J hat pound force feet. Forget the hat then. Pag Cartesian vector lang naman siya. So yung Cartesian vector notation to, it's a lot simpler. You can use yung right hand rule by rotating about, by using yung right hand rule natin. Our thumb should be pointing at the negative y-axis dito. So that means yung sign natin is, so yung thumb natin is pointing away from our body dito. And that would mean negative 129.904 J siya. There we go. Now, if you don't like using yung right hand rule, we can use this mathematically rin naman. So let's try naman yung vector analysis naman. No? So let's try yung cross product. Let's do it mathematically. Okay, and see if we could arrive at the same answer of 129 J hat. In this case, we're determining the vector moment M equals to the summation of all the cross product position vector R and force vector F. Okay. Good thing about is we have two forces theta and two potential force position vectors, which is ROA and ROB. And all we have to do na lang is just get the summation of cross products na to. And how do we determine the FA and FB? That's easy because we can just put it here. For FA, that's just 8 inches, 8 inches J hat. That's gonna be no, sorry. So FA here is negative 25K, K hat, and then FB here is 25K. So using the principle of transmissibility, binabaan na lang natin yung force natin dito to have yung K hat na yan. Okay? Just so imagine lang yun ulit. Ito siya. So, or this one. Creating yung couple moment na yan. Kaya naman ibaba yung force eh. Because due to principle of transmissibility. Okay? And then next up is yung RA natin. RA is simply 8 J hat. And then RB is 6 J hat plus 8. So 6 I hat plus 8 J hat. And then whatever using K hat nito, which is basically 6 sine negative 6 sine of negative 6 sine 30 degrees K hat. There we go. Sorry, there we go. So 6 cosine 30 degrees pa pala. K hat times 25K. And this will give us 2 3 by 3 matrix. And this will yield this way. So as you can see, there's a lot of zeros, so there's a lot of cancellation here, leaving only 8 times negative 25. And with the other one naman, so you can simplify this further. So we have negative 200 I hat, 0, 0, 200 I hat, minus 129,904J, and guess what? Negative 200 plus 200 is 0, leaving us with negative 129 or 4 J hat. There we go. Oops, wrong symbol. This should be clockwise. So, the positions ng FA natin dito, pinagtasayan yung pinakadulo dito, and its horizontal distance. 25-pound force here is down at negative 25K. Okay? So, this is negative 25K. So, going upward to. So, namang ito yung negative 25 because going downward siya. So, doon na nagmamatter yung sign dito. Okay? And remember, due to principle of transmissibility, ito yung line of motion niya. So, hence, tatagos yan dyan. Ito papasok ko naman dito. Okay? So, at this particular point, meron silang K, and then this one is going down naman. Hence, negative 25K, and then positive 25K dito. Pound force.